rational functions by using their parent functions. The parent functions that we will explore in this video are
quadratic functions, exponential and logarithmic functions, radical functions, rational functions, and even trigonometric functions,
trigonometric. Function of a quadratic function and the basic translation of the function, and now we're going to look at that for some other functions. So the next one that I'm going to look at is an exponential function. Exponential function, and we've got a basic exponential function with a variable in the exponent, and that's some base raised to the x. Translation of the exponential function is b to the in parentheses x minus h and all of that plus k. Now we're just going to come down here and write all of these, and you'll start to see a very nice pattern for remembering left and right, up and down translations. How about logarithmic? We have a basic logarithmic function. We can call that log base b of x. How about that? And our parent function is translated by the log base b of in parentheses x plus h, x minus h, just as the others, plus k. I was getting ahead of myself on that. Zoom out just a little bit. Let's try another one. How about radical or square root functions? I'm just going to say a square root function. And let's say f of x is the square root of x, the most basic of all square root functions. The parent function is f of x equals the square root of x. Now, if you were working out a pattern on how to translate this function using the same rules, we're going to keep the h with the x under the radical. X minus h, and then off to the side we've got a plus k. Let's try rational functions. Do we remember the parent function of a rational function? F of x is 1 over x. It's a rational function. We've got a variable, a ratio in the denominator, and because my left or right translation is going to stay with that x, it's going to stay in the denominator, and we're going to get 1 over x minus h plus k. And now let's come on over to even trigonometric functions, and there are many types of trigonometric functions. I'm just going to do the basic sine function. F of x equals the sine of x. We would take f of x equals the sine, get those parentheses because the h remains with the x, x minus h plus k. When you translate left or right, when the function moves left or right, in a trigonometric function, that's called a phase shift. And we'll learn all about that stuff as we get into trigonometry, precalculus, and even AP calculus. So now let's look at what happens when a function goes through a transformation. That is to say, a change in shape, either a vertical stretch or shrink, or a horizontal shrink or stretch. When you look at the rules for stretches and shrinks, you can see that the vertical stretch or shrink is straightforward, the constant being out in front of the function and a whole number greater than 1 signifying a stretch. But when you look at horizontal changes, you will see that a whole number greater than 1 signifies a shrink. Let's look at some examples. How about this one? We have 3 times the log base 2 of x minus 1. That's on the outside of the function. It's not attached in parentheses to the x, so we can say that that is a vertical. It's greater than 1. We'll call it a vertical stretch. And this one way all off to the side here means that it is translating down 1. The outside of the radical and this radical function, and we know that that will be a vertical. It's less than 1. It's a vertical compression. Less than 1 vertically is a number between 0 and 1, non-negative number, and now we have going 2 up. So here we have an exponential function. It is a base raised to an x power, and we know that this number is attached to the x in the exponent, so this is a horizontal stretch or shrink. And remember the rule for horizontal: if it's less than 1, it becomes a stretch. So this is an e to the x function that is being stretched horizontally by a factor of 0.5. So we're going to call that a horizontal stretch. And look at this minus 6 off to the side. We know that this function translates down 6. What if we had a negative on the front of that function? That would be a reflection on the x-axis. So we can see in this example that because the 2 is attached to the x together in that parentheses, we can assume that we're going to have a horizontal stretch or shrink. And because the 2 is greater than 1, we're going to call it a horizontal shrink. This is a shrink horizontally. And then out here off to the side, we see that this function is translating up 1.
How old are you, Jethro?
He's my 15-year-old leader of the pack. When Jethro was just 1 year old, he was hit by a car and he had extensive surgery all on his back, hip, and leg. But it's amazing, after 15 years, he's still swimming around and he's just as spunky as ever.
Thank you for watching.